Hello friends, welcome to Risingpearl.com. This is series 7 where we are learning a whole lot about quadratic equations. This is webisode number 8. Friends, today's topic will be solving questions on quadratic equations. This is part 2. If you recall, I think it was a little while ago, I think maybe episode 3 or so, where we started taking a look at what kind of questions you will be getting on quadratic equations and how do we solve them. So in this particular episode, we are going to take a look at some quadratic equations and see how we can find the roots of those quadratic equations. So the first question is that find the roots of x squared plus 6x minus 7. Now in the last few webisodes, I think it was last 3 or 4 webisodes, we looked at how do we actually solve quadratic equations, and we realized we can solve them using middle term factorization and also completing the square method. I have also mentioned to you that we would want to use middle term factorization as much as possible, and when it is not possible we will really then go to the completing the square technique. So let's take a look and see if we can actually crack this with middle term factorization. So we have 1, the coefficient here is 1, and this is minus 7. So 1 times minus 7 is equal to minus 7. Minus 7 is a prime number, so we can really have 7 and 1 in which we can split this. So if we take 7 and if we take 1, if we add them, so there is minus 7, one of them can be negative. So we have plus 6, so we can do plus 7 and minus 1. So if you multiply, you will get minus 7, and if you add them, you will get plus 6. So we will write this as x squared plus 7x minus 1x or minus x minus 7 equal to 0, or from these two we will take x common, the first two terms, so it will be x plus 7, and from here we will take, from these two terms we will take minus 1 common, so we will get x plus 7. Why it is plus? Because minus 1 times plus 7 is minus 7. So this is equal to 0, or between this term and this term we'll take x plus 7 common, x plus 7, then for the first term we will have x, and then we have minus 1 equal to 0. So this can be equal to 0, so x plus 7 can be equal to 0. Also x minus 1 can be equal to 0. So if this is equal to 0, we see x is equal to minus 7, and if this is equal to 0, we see x is equal to 1. So we say that this and this, minus 7 and 1, are the two roots of this quadratic equation. Really straightforward, not trying to use the complete the method technique. It did not take us that long, nor did it. Alright, let's keep going. So the next step is, how about we try and find the roots for 100x squared minus 20x plus 1. So here the coefficient for x squared is 100, so we have 100 times the constant term is 1 times 1. So this will be 100. So we can split 100 in different ways. So we can do 20 times 5. We can do 10 times 10. We can do 2 times 50, so on and so forth, right? Lots of choices. What we have to do, we have to get to minus 20. One important thing to note is here we actually have this as plus. So either we take both plus for both factors or both minus. So if you obviously take both plus, this will be 25, this will be 20, this will be 52. But if you look at this one, if you take both plus, you will get 20, but we have minus 20. How about if you take both minus? If you take both minus, you will be getting minus 10 times minus 10, which will actually be plus 100, and it will be minus 20. So this is the factor that we are going to use. So we will have 100x squared minus 10x minus 10x plus 1 equal to 0, Or from here we can take 10x common. So 10 times 10 is 100 and one more x will be here. And 10x is outside, so we will be we'll have minus 1 inside here. Now from here we will take minus 1 common. So we will get 10x minus 1. This will be equal to 0. Or from these two terms, this one and this one, will take 10x minus 1 common. So we will get 10x minus 1 equal to 0. Or now this could be 0, this could be 0. So if you look at this, actually they are both identical, meaning that you can say 10x minus 1 0, and similarly you can write, so this can be equal to 0. Similarly this can be equal to 0. But you will get the same value for both of them because both are same linear equations. So from here you will get x equals 1 by 10, and from here you will get x equals 1 by 10. So in other words, this particular quadratic equation has only one root. Now this is kind of important for you to keep in mind, that this particular quadratic equation has one root, which is 1 by 10. Both values are same. Now very briefly, I know that we are kind of going a little bit on a different direction. If you recall, I think it was like 2 series ago, I think it was a polynomial series on polynomial, where we were looking at how we can graphically represent a quadratic polynomial. And if you recall, we said sometimes you can have graphs that go like this, meaning that the graph touches the x-axis only at one point. So then there will be only 1 0 or one root for those equations, or 1 0 for the quadratic polynomial. So this is one such case where we have the graph touching the x-axis at only one point, which is 1 by 10. Alright, so let's keep going, let's keep moving. Now let's try to solve this particular quadratic equation. So 2x squared minus x plus 1 by 8 equals 0. So here what we have is, we have 2x squared minus x plus 1 by 8 equals 0. So friends, first and foremost, we would want to get rid of the denominator. So what we are going to do, we are going to multiply both sides of an equality by 8. Why 8? Because 8 is the denominator. Now recall that if you have one equation, something equals something, you can multiply both sides by the same number and it does not change the equality. So here I am going to multiply both sides by 8. So we will get 16x squared minus 8x plus 1 equal to 0 times 8 will be still 0. So this will be equal to 0. And now let's see if we can do middle term factorization. So the first term is now going to be 16. Coefficient of x squared is 16, and the constant term is 1. So 16 ones are 16 obviously. So we can break 16 as 4 times 4. We can do this as 2 times 8. 1 times 16. And what we want is, obviously this is a plus. So the signs have to be either both positive or both negative in order for the product to be plus. If you look at it here, the middle term, we need minus 8. So if we do minus 4, that works. For other combinations, we will not get it. So we are going to split this as, so 16x squared minus 4x plus 1 equal to 0. Or from here, let's take 4x common. So 4 4s are 16 and x will come here, minus 1, because 4x, this is 4x, minus 1. From here we will take minus 1 common. So we will get 4x, minus 4x, and minus 1 because minus minus will become plus equal to 0. So between these two we will take 4x minus 1 common. So we will get 4x and minus 1. So looks like this is again another example where it looks like we will have only one root for this quadratic equation because both linear equations are going to be same, and which will be 4x minus 1 equal to 0 or 4x equal to 1 or x equal to 1 by 4. So in this particular example there is only one root for this quadratic equation and it is 1 by 4. Let's see if we can take a look at one more question. Find the roots for this quadratic equation. Now here this is in a standard form. So what we have is this is the coefficient for x square and this is minus 2. So our product will be 5 times minus 2 or minus 10. So now we can actually write 10 as, this is minus, but 10 as 10 times 1 or 2 times 5. This is minus, so we can have one of these terms as negative. So if you look at this, only one of them can be negative. So you can take plus 10 minus 1, that will give you 9. If you take minus 10 plus 1, again it will give you minus 9. So if you take 5 minus 2, you will get 3. The point I'm trying to make is, using middle term you cannot solve this. So we are not able to get any factor that we can break this into. So you know what it means. It means that we are really going to use completing the square method. So alright, so what are we trying to do? We are trying to make this a whole square. So we multiply both sides of the equality by 5. So what we get is 25x square. Why did we multiply both sides by 5? So that we can write this term as 5 square. So 25 square minus 5 6 are 30 x minus 5 2s are 10 equal to 0. Why 0? Because 0 times 5 is still 0. So now this is our equation. So we have to keep going. So we will now write this as 5 square x square minus 2 times 5. And now, so we have to write something in here. This is the q term. Remember in the last few webisodes where we talked about how to solve equation using the completing the square method. So now 2 times 5 is 10. So if you put 3, then it will be 2 times 5, 10 times 3, 30. Right? So this is 3. So we are actually going to add 3 whole square minus 3 whole square and then minus 10 equal to 0. I think let us just make sure that we kind of block this out. So our equation will be now 5x minus 3 whole square. So the first 3 terms have been taken into account. 5x minus 3 whole square. Now let's get these terms on the other side. So you will have 10, the minus 10 will become plus 10, plus this minus 3 square will be plus 3 square, or it will be 10 plus 9 or 19. So now we have 5x minus 3 whole square is equal to 19. So now taking square root on both sides, what we can do is we will get, so this is the advantage of completing the square technique, that if we can get these two terms of x, all the terms of x into one whole square, we can simply take a square root, right? So this will be equal to plus minus square root 19. So let's take each one of them separately one by one. So we have 5x minus 3 whole square, right? So this side will become 5x minus 3. This will be equal to plus minus square root 19. So we will have, let's clean this up here, give us more space. 5x, so we will have 5x minus 3 equal to plus square root 19, or we will have 5x minus 3 equal to minus square root 19. So if we solve this here, so we will get 5x equal to, the minus 3 will become plus 3, 3 plus square root 19, or x will be, we divide both sides by 5, it will be 3 plus square root 19 divided by 5. And in this case we will have, so 5x will be equal to, this 3 will become plus, but then we have 3 minus square root 19, or dividing both sides by 5, we will get x equal to 3 minus square root 19 divided by 5. So for this particular quadratic polynomial, quadratic equation, the two roots are 3 plus square root 19 by 5 and 3 minus square root 19 by 5. So as you can see, friends, why it is very important to know the completing the square technique, because there are times when you cannot do middle term factorization. Even if you want to, you cannot do that, and then you have to use the completing the square technique. Let's see if we have enough time to maybe take one more question. I think, well, we will take some more questions in the next webisode.